Alright, I apologize. The video recording decided to shut down on me. So what we were saying is if we want to evaluate a polynomial function, if you notice the notation p of x, if I'm asked to find p of -4, you see from the notation that the -4 is sitting in the place of the x. That's basically all this is asking me to do. We want to substitute the value -4 for x. So everywhere I see an x in the polynomial, I'm just going to replace it with a -4. You notice I am using parentheses around the value that I'm substituting. That's because, if you remember, we've talked about before that the quantity -4 squared is not the same thing as just -4 squared. So using parentheses when you substitute is very important. Also note that for the homework and the test, I will be expecting to see that substitution step. I'm going to show one more step here before the answer. You do not have to show this step. This would be -2. -4 times -4 is 16, plus -4 minus 1. You can just enter that into the calculator exactly the way it looks, and hopefully we should get -37. So a lot of times we'll be asking you to report this answer in function notation. To do that, what it's asking for is for you to tell me that p evaluated at an x of -4 gave me a -37. So that would be the answer. One way we use what we just did is in an application for a projectile motion. A projectile is fired upward from the ground with an initial velocity of 240 feet per second. Neglecting air resistance, the height of the projectile at any time t can be described by the polynomial function p of t equals -16t squared plus 240t. What's important about these application problems is that we understand what each piece stands for, so we can determine what is being substituted and what we're solving for. So in this case, the two things that we need to identify: what does p of t represent and what does t represent? Well, the t is probably the easier of the two, right? You see up in the problem it says at any time t. So t represents time. And notice that the velocity up here is given in feet per second. So the time is in seconds. The p of t, if we have a given time, the problem says what we can determine is the height. So the p of t represents the height of the projectile at any given time, and the height is in feet. So to solve this problem, it works a lot like the one we just did. If we want to find the height of the projectile at a time t equals 3, that means we're going to substitute 3 in the place of t, just like we worked the previous problem. So if we look at the given polynomial equation, if I want to evaluate it at a t of 3, we replace the t with that value 3 in every place it shows up. And then all you have to do is enter -16 parentheses 3 squared plus 240 parentheses 3. And hopefully from the calculator that will tell you it's 576. So to give the answer in function notation, what that means is the height at t equals 3 seconds. The projectile is at 576 feet. And that's pretty much what give the answer in sentence form with the correct units is. What we just said was the height of the projectile at t equals 3 seconds is 576 feet. So that's all there is to the application. So the last thing that we're going to look at in this lesson is also a review. If you had 105, we covered the exponent rules. We're not going to cover every exponent rule here because they're not necessary for what we're about to do. The ones that I'm covering are going to be ones that we need later in this chapter for the work that we're going to need to do. The first one we're going to look at is the product rule. And basically, this is just multiplying like bases. So if you've had me before, you've probably heard me say this. If not, you will hear me say this a good bit. There are some common trends in math. One of them is that multiplication tends to run or go hand in hand with addition, and that will hold here. If we are multiplying, my operation is multiplication like bases, then we're going to add the exponents. So if I look at my first example, I have 2 to the third times 2 to the fifth. So the common base is 2. That's not going to change. We'll keep the base. We're going to add the exponents, and that gives me 2 to the 8th. Now I want you to note here, throughout the exponent rules, you're going to see that the instructions say demonstrate the rule, simplify the exponent, and simplify the answer. So I don't want you to just type into the calculator 2 to the third times 2 to the fifth and give me an answer. That's not what I'm looking for. I want to make sure that you understand when we multiply like bases, we have to add the exponents. We're going to need that for the coming material. So I want you to demonstrate the rule by showing me that we keep the base and add the exponents, and that becomes 2 to the 8th. Now this is an acceptable answer. If you want to put 2 to the 8th into the calculator after this step and tell me what it is, that's fine. But don't go straight to the answer. I can't give credit for that. Okay? For the second one, we have the common base of x. They are being multiplied. So again, we're going to add the exponents. So this one is going to be x to the 11th. Now the next thing that you see, what is the difference between these two, is something that comes up a lot, especially when we're first starting with multiplying, factoring and stuff, trying not to get mixed up which thing we're supposed to do when. The key to this is, of course, to look at what operation am I being asked to do. So in A, the operation is multiplication. So this one is the product rule that we just learned. We're multiplying the like bases y times y. So that means if we multiply the like bases, we're going to add the exponents. So this one is y squared. For B, the operation is addition, not multiplication. So this is just collecting like terms. 1y plus 1y just gives me 2y. So be really careful as you're working through the problems that you pay careful attention to what operation you're being asked to do and what strategy that means to take. Okay? The next rule that we're going to look at is the quotient rule. And this one is going to be dividing like bases. And similar to multiplication and addition going together in math, division often goes together with subtraction, and it does here too. If I'm dividing like bases, then I'm going to subtract the exponents. Now note, it's always the exponent that's in the numerator or the top minus the exponent or the one that's in the bottom. Okay? Now, I'm not going to introduce negative exponents in this lesson, so they're all going to come out positive. We're not going to need negative exponents in the material that's coming up, so I'm not going to recover that here. So all you basically need to know is that basic rule. So if I have 2 to the 7th divided by 2 to the 3rd, my common base is 2, and we're going to subtract the exponents, the one in the top minus the one in the bottom. So this is going to be 2 to the 4th. Again, I do want you to demonstrate the rule, and then 2 to the 4th, you can leave it like that. If you want to put 2 to the 4th in the calculator, that's fine too. For the second one, my common base is x. We're going to subtract the exponents 8 minus 3, since this is a division problem, and that leaves me with x to the 5th for the answer. The power rule, you will probably hear me say a good bit that it's the power to a power, because we have a base and it is raised to an exponent, and then that entire thing is raised to another exponent. So it's a power to a power. When we do that, we're going to keep the base again like we normally do. Now we're going to multiply the exponents. So for this first one, my base is x. We have the x raised to the 3rd and that whole quantity raised to the 2nd. So we're just going to multiply the 3 times 2, and that gives me x to the 6th. Now the second one, we see a fraction, and that might make us cringe. But remember, we have a calculator. Don't let fractions worry you, because the calculator doesn't really matter if it's a fraction or not. We still have a base of x, and we're going to multiply 2/3 times the 3. If you want to write that as 3 over 1, you can. I'm not going to ask you to demonstrate how to solve this problem. You're welcome to use the calculator. We know that the base is going to be x. You can use your calculator and enter 2/3 times 3. And if I did it mathematically, we know those 2 3's were reduced to 1. So you should get from the calculator x squared. But all you have to do is enter the 2/3 times 3 in the calculator and tell me x squared. That's all that's required. Okay? The last one is now a product to a power. So now we don't just have like the x in the previous one raised to a power. There are actually 2 different things inside the parenthesis. So when we have that, we're going to raise each one to that exponent. So the AB you can think of as a to the 1st, b to the 1st, raised to the n. Remember, if there's not an exponent showing, it's a 1. So then it's going to be a to the 1 times n and b to the 1 times n, which would just give me a to the n, b to the n, which is what my rule says. Okay? So if we look at this first example, remember the 4 is to the first power, and so is the x. So this is going to be 4 to the 1 times 2, x to the 1 times 2. So that gives me 4 squared, x squared. You can leave it like that. If you want to simplify it and tell me that that's 16x squared, you can. Either of those two answers will be perfectly acceptable. For the next one, we have 3 to the first, x to the fourth, and that's raised to the second power. So it's going to be 3 to the 1 times 2, x to the 4 times 2. So we'll get 3 squared, x to the 8th. And again, you can leave it like that. If you want to simplify it and say that's 9x to the 8th, that's fine as well. Now the next one does have something in it that we'll need to discuss, but this shouldn't come up very often for us here. I have a negative inside this time. What I usually do when that happens is just kind of think about it up front. A negative sign is really the same thing as a negative 1. And if I asked you what negative 1 to the third power is, that would mean to multiply negative 1 times itself 3 times, and that just gives me a negative 1. Well, that's kind of a general thing, not just to the third, but a negative raised to any odd power is going to end up still being negative. So what that means is my answer is going to be negative. So I'm just going to go ahead and bring that down. And then you can think of it just like we did before, 5 to the 1 times 3 and x to the 6 times 3. So we'll have negative 5 to the third, x to the 18. And then again, that answer is completely fine. If you want to cube the 5 in the calculator, you can do that as well. So the last part is just a couple more examples to kind of look at them thrown together. So the first one, remember what we need to do is look at what operation is given to determine what strategy to take. The operation here is multiplication of like bases of x. So that means we want to add the exponents. So this is just going to give me x to the 11th. For the next problem, we have coefficients 2, negative 3. We have variable x and a variable y. So basically we just look at them separately. I know that 2 times negative 3 is negative 6. If I have x to the 5th times x to the 1st, those are like bases being multiplied, so we're going to add the exponents. And you notice the second term, the negative 3x, there's not a y. So we're just going to bring down the y that's in the first parenthesis. So then the final answer is just negative 6, x to the 6, y. Now for the third one, you see I have that negative inside again. The power isn't odd this time, it's even. Well, if I was to raise negative 1 to the 4th power, that means to multiply it times itself 4 times, which would end up being a positive. So anytime we have a negative raised to an even power, the answer is going to come out positive. So we don't need to worry about the negative here. We're just going to look at this as 3 to the 1 times 4, y to the 1 times 4. So that's going to give me 3 to the 4th, y to the 4th. And again, you can leave the answer that way. If you want to evaluate 3 to the 4th in the calculator, you can. And lastly, this one is a power raised to a power. So that means I'm going to multiply the exponents, giving me x to the 15. Alright, that is the first lesson. Thank you for listening, and tune in for the next one.